Welcome students. In our previous class, we have discussed about PN junction diode. What is PN junction diode? What is its biasing and the about the depletion region in mobile charge carrier, and the minority charge carrier, majority charge carrier, and biasing of diode. Okay, we have discussed. And there is another type of diode we have discussed, that Zener diode, which is which has reverse breakdown voltage, and this voltage depends on the doping concentration and the property of semiconductors. Okay, and usage of Zener diode we have discussed, that Zener diode basically used as voltage regulator, and in different cases we can use Zener diode. Today we will discuss about some application of diode. Okay, so applications. First application of diode is normal diode is rectifier. Rectifier means AC to DC conversion. We know AC means alternating current, means alternating voltage direction of current is always changing. We have to convert this AC to DC. Okay, this is known as rectifier. Okay, so we know the AC signal is like this, time based voltage, and we have to convert the direct current, means direction current always. So here first we are going to show half wave rectifier. So half wave rectifier circuit is very simple and very easy circuit. So you can see here, just here this is the input source. Okay, see the signal input source, and input source. So here input signal is like this, time versus voltage graph. This is called peak voltage, upper peak voltage and lower peak voltage. And here if you see, as input signal is AC, means sometimes suppose initially upper side is positive and lower side is negative. Then now diode is in forward bias because P side has positive voltage and N side has negative voltage, this negative terminal. Okay, so the current will flow from P to N, Okay, so this direction current will flow. When for first half, suppose for this first half, then we get current. And if I draw the first half output, we get like this. Okay, this is the first half's output. And then for second half, I know one cycle is completed from 0.2 this point. Okay, this is the complete cycle. There is one half is upside of 0 voltage and another is the lower side of 0 voltage. So this is the first half. And for second half, means upper point is now negative, lower point is now positive. Now the diode is in reverse bias, because at P terminal the voltage is, means potential is negative. Okay. So now diode is in reverse bias, so no current will flow in second half. Okay, so second half we could not get current, but third half again we get current for this first half of second wave, and again here no current we get. If I draw another half, then we get output current like this. Okay, so here you can see the direction of voltage value of voltage is not same, sometime maximum value, sometime 0, but direction of voltage means always the terminal is always, one terminal is always positive and another terminal is always 0 or negative. Okay, means we are able to uh, convert AC to DC. Okay, here this is written that for first half cycle signal S1 is positive, S2 is negative. S1 means, now this is the S1 and this is S2. Okay. And so the PN junction diode in forward bias, then current flows to other output voltage obtained across circuit. Okay. So here you can see that one half of this cycle is neglected. So to get also, so we get power near about half of full wave. Okay. So there is another rectifier called full wave rectifier, where the negative part of input signal is converted into positive part. This is called full wave rectifier. Here for full wave rectifier, we need a transformer. Okay, called, and this is called center tape transformer. Okay, center tape transformer means we know that transformer has two coil. One is called primary coil, another is called secondary coil. Okay, in primary coil there is two terminal. Okay, in secondary coil, for normal transformer, secondary coil has two terminal, but in center tape transformer there is three terminal. Three terminals. The another terminal is coming from the middle of the winding of secondary coil. Suppose this is the secondary coil winding, this is the wire, and this two terminal of a wire, and the middle point of this wire we connect another wire with the middle point of this wire. There is three terminal. This is called center tape transformer. Okay. This is the center, and there is another terminal. Another. This is another terminal. Okay. This is called center tape transformer. So to draw the center tape transformer, we will draw like this. Okay, this. Or here is also primary coil. The AC signal is connected to primary source AC. And remember, transformer is always work in AC. We cannot use transformer in DC. If you connect a transformer with DC source, then transformer will burn. Okay, and here is a center tape transformer. So now what we will do? So this is a terminal. So first we connect this terminal with AC source. Okay, AC, and in output we have to use two diode. Okay. One diode is like this, and another diode. These two diode. So suppose this is D1 and this is D2. Okay. And this is center, and connect this two terminal, and then extend this terminal, middle terminal, not connecting. This signage denotes that the central terminal wire is not connected with this wire. Okay. And extend this, and now we are able to convert AC to DC. Here AC source is applied, and we get here DC source, DC output. Okay. And we can use another load. Load means our external device. Okay, device is act as load resistance, load RL. Okay. Now just I am going to explain. Here input signal is like, first let me draw input signal. This is input signal, time versus voltage, VAC or V input. Now we have to draw the output signal, time, voltage out. So for first half, suppose for first half of input signal, this is suppose A terminal, no need here. Suppose this is A terminal, this is B terminal, and this is center C terminal. Okay. So C terminal is chosen as zero potential, means C terminal, suppose C terminal is grounded. We can choose. Okay. So C terminal voltage is 0 volt. Now suppose A terminal is positive, B terminal negative. Okay. Suppose at an instant A terminal is positive for this. Okay. Suppose at any instant T, A terminal is positive, B terminal negative. Now you can see here that so P side is positive of D1, D1 in forward bias. Okay, D1 now forward bias, and D2 you can see P terminal is negative, means here forward bias positive and this is negative, means D2 is in reverse bias. Now D1 forward, D2 reverse, so D2 will not conduct, only D1 will conduct, and so current will flow through this and cannot go this side because D2 is in reverse bias. It have to go along this side. It has to go along this side, means suppose EF along E to F, through E to F, current will flow through E. Sorry, 1 minute. F, E to F, E to F. Okay. So first up, we can get output signal like this. For second half, suppose for second half, A is negative, B is positive, and C chosen as 0. So now D1 is in reverse bias and D2 is in forward bias. Then current will flow through D2 like this path, but cannot go to this side because D1 is in reverse bias. So current has to go this side, and we get also again E2F, same direction current for negative half cycle, another half cycle. Okay, so we get again same type. That means we are able to inverted the negative part of input signal to positive. Okay, that's why it is called full wave rectifier. Explanation is written here. You can study, and we have to write. Okay. Another terminal rectifier is here. So if you want to convert AC to DC without using center tap transformer, you can use another type of rectifier called bridge rectifier. Here we need 4 diodes. Okay, and this is also out of syllabus. This is also your out of syllabus, but I am show you. I am going to show you. So the diodes are connected like this. Okay, so you can see P side and N side here, N side and P side connected here and connected with one terminal of transformer, and another 2 diode here, P side and N side of diode connected to the another terminal, and 2 N side is connected to one side and 2 P side connected to another side of out. Okay. Now let me explain. Suppose for one at any instant, this is positive, this is negative. Suppose this terminal is A, this terminal is B. Then diode D1 is in forward bias, D2 reverse bias. So current will go through this, but current cannot go through this because this is in reverse bias. Okay, so current has to go like that, right? And we get, and suppose E to F, current is flowing through E to F. And for next half cycle, suppose A is negative now, B is positive. Then current will flow through B. Okay, then will go through this path, cannot go through this path, and current will go through and cannot go also this path because this is in reverse bias now. Means D4 and D1 are in reverse bias, and D3 and D2 are in forward bias. Then current will go through this way, then through E2F again. Okay, then F2 this point and then this point. Okay, this path cannot go this path because this is, they are same potential. This point potential and this point potential is nearly same, or maybe this point potential is slightly higher than this point. Okay. So cannot go this path. Current will go for, so we get here same direction of current for 2 half cycle. Means we are able to convert it AC to DC. So here different type of diode. Light emitting. I have told we are the completely controlled by semiconductor, means or electronic device, and our life is completely semiconductor dependent, or means LED dependence or diode dependence or transistor dependence. Okay, basically semiconductor dependence our life. So light emitting diode is, this is also based on semiconductor, but here we cannot, and this is a special type diode. Here we cannot use silicon or germanium. So this is property because in case of silicon and germanium we get radiation with millimeter range wave or meter range wave, which is not the detectable by our eye, or we cannot get light wave from silicon or germanium diode. So we need different type of diode. This is the some alloy. In some alloy used as semiconductor like gallium arsenide, gallium arsenide, phosphide, silicon carbide. Okay, this type of material is used, alloy. Basically, this type of alloy is used to produce diode of different color. Okay, and depending on the doping concentration and material property, we can change the, or we can make different color of diode. Okay, and symbol of diode is like this. This arrow is denoting that light is emitting from diode. Okay, so when a conductor of conduction electron makes a transition to the valence band to fill up the hole of p-n junction, then extra energy may emitted as photon. Okay, photon. So if the wavelength of the photon is visible range, okay, one can see emitted light. So the radiation also coming out from silicon and germanium, and very small amount also, these are the non-radiative transaction is there, but here radiative transaction is here. And the radiation wavelength, when radiation wavelength between 380 nanometer to 780 nanometer, then we can see the emission of light. Such p junction diode is known as LED. Okay. And condition to get light from LED, very important. So this is also basically a PN junction diode. One is potential barrier should be between 1.8 electron volt to 3.2 electron. Potential barrier means here the valence band, potential difference between valence band and conduction. This should be 1.8, means should be very large. And another point is momentum of hole is equal to momentum of electron, so that the collision is, during collision they can emit light. Momentum of hole and electron, due to collision of this electron and hole, we get radiative transition or radiation, and having radiation 380 nanometer, 780 nanometer. For silicon and the wavelength falls in infrared radiation, and also momentum of hole and momentum of electron not same. So LED cannot be made by this type of semiconductor. LED made of gallium arsenide phosphide, gallium phosphide. It is a photodiode. There is another type of diode, photodiode. Photodiode is most important diode. It can convert solar energy into electrical energy directly. And also in solar cell mainly basically consists of large number of photodiode connected in series and parallel. Okay. So photodiode is a semiconductor PN junction device that convert light into electrical current. The current is generated when photons are absorbed in photodiode. When photon enter into diode, suppose this is a photodiode, there is a junction, and due to diffusion, there suppose this is p side there is in mobile charge ion, positive negative. Okay. And due to hole and combination of electron and hole, there this region is now neutral, means there is no carrier. But when light incident on it, the bond will be break. Okay. For sufficient wavelength, or sufficient energy of radiation enter into junction, then the electron hole pair will be created, hole electron pair, and then hole will go this side, electron will go this side, because there is a immobile negative ions. So negative ion attract the holes and positive ion attract the electron, and hole will go this side, electron will go this side. Okay. So if we connect a external resistance, then we get a current from p side to n side. Okay. Basically normal diode, you can see, if we connect a source, current will flow from this direction. Okay. But in case of photodiode, when light is entering into diode and then we connect a resistance R, then current will flow opposite to the previous direction. Okay. Current will flow like this. Okay. That means for discharging of battery, flow of direction is here clockwise according to this picture, but here the due to when the light is falling on the diode, photodiode, then current is reversed, means if you will connect your battery can be charged, recharged. We can recharge our battery by photodiode means solar cell is a consist of large number of photodiode basically. Okay. So working principle here, when light of energy h nu fall on photodiode, here h nu is the energy gap, more than more electron volt, more electron move in valence band to conduction band. Due to this current, the circuit of photodiode reverse bias. So I have told current, we get a reverse current, reverse bias linkage. A light increase, as light intensity of increase, the photocurrent goes increasing. So photodiode you detect light intensity. Example of video camera. In video camera also photodiode used. In solar cell the consist of large number of photodiode. So it constructs a graph. Also I have to draw graph for LED. 1 minute. For LED, the graph, reverse bias graph is VI graph, voltage versus current. For reverse bias graph is same to same as previous, but for forward bias, the diode curve is like this. In case of silicon diode, the graph is like this. Okay. This is 0.7 volt, 0.7, but in case of photodiode, this must be this voltage greater than 1.8. Okay. Knee voltage should be greater than 1.8. For red LED, we use the voltage is 1.8 volt, more than 1.8 volt or 2 voltage is minimum voltage equal. But for blue LED, we need minimum voltage 3 volt. Okay, blue LED consume more power, and blue LED need more voltage than red LED. You can uh, practically you can do or check this. Okay, so for red LED, minimum voltage equal 1.8 or 2 volt, but for blue LED, minimum voltage equal greater than 3 volt or near about 3 volt. And for photodiode providing reverse bias current. So here voltage versus current, if I draw a graph, so for when no light entering into diode, okay, so the characteristics, suppose for if I apply voltage, suppose this is a photodiode, okay, and here battery is connected like this, means forward bias, battery is connected in forward bias, okay, and no light is coming entering into this, then the diode current reverse bias current is very low. For reverse bias means, suppose battery biasing is reversed, now for reverse bias, low current we will get, and for forward bias like this. For forward bias we have to change the polarity of battery, and we can forward bias for forward bias battery like this. Okay. But when light entering into it, okay, so we get, suppose battery is connected in reverse bias. Now battery is connected in reverse bias. So reverse bias, photodiode provide large number electron hole pair created and provide large amount of current in reverse voltage. Okay, reverse direction. And in forward bias they are also like this, we get, and we can use in forward voltage sufficient forward voltage for low value of forward voltage. Okay, for low value of forward voltage, the now diode able to charge the battery for sufficient high voltage of battery. That means battery of diode should be greater than the voltage of diode, photodiode should be greater than voltage of battery, then battery will charge. Okay. So like this region is used uh, as solar cell. So with increasing intensity of light, we get like this reverse bias curve. Okay. With increasing intensity, reverse bias current will increase. Suppose this is I1, I2, I3, I4. These are the intensities, not current. Intensity. Okay. Dark current is when no current is incident on the reverse bias situation. Current on the photodiode is called dark current. Solar cell. Forward bias of photodiode. It's called solar cell. I have told in case of solar cell, here we use forward bias, means this is forward bias is connected like this. But when light is incident diode, when diode provides reverse voltage and battery try to provide forward voltage. So if diode voltage is higher than battery voltage, then diode able to charge the battery. This is called solar cell. In solar cell, large number of diode is connected in series, so that solar cell voltage is greater than battery voltage. Basically, solar cell normal we use our solar cell provides voltage near about 15 to 18 volt to charge 12 volt battery. That means large number of diodes are connected in series, so that they can produce 15 to 18 volt. So for solar cell, characteristics curve will be, there is no like this term is used, negative portion also there. You can draw like this. And solar cell, this is the forward bias, and forward bias of photodiode is called solar cell. Okay. This is the forward bias region. This is the solar cell working principle. During when photodiode uses solar cell, the forward bias current is used. Okay. This is the forward bias. Okay. So now we have some problem we will discuss. In given circuit PN junction diode, the calculate the current through it. I have to calculate current through it. So and here told diode is ideal. Ideal means there is no potential drop through diode. Okay. Basically, for normal silicon diode, the potential drop is, I have put 0.7 volt, and for germanium 0.3 volt. Okay, 0.3 volt. And this is for germanium diode, this is for silicon diode normally. But for ideal diode, the voltage difference is 0. I have to choose. Okay, I have to take the voltage difference across diode is 0 for ideal diode. Okay. So here voltage you can calculate that here is, suppose this is 0 volt, then this is minus 1 volt, and this is 0 volt, this is minus 3 volt. Then first check that this side voltage is minus 1, this side voltage is minus 3. First check this diode is in forward bias or reverse bias. So forward bias means P side should be positive, N side should be negative. So here P side minus 1, N side minus 3 means the P side is more high voltage, higher voltage than N side. Minus 3 is smaller than minus 1. Okay. So this is forward bias because the P side is higher voltage, P side is higher voltage than N side. So diode will conduct, and the potential difference across resistance will be minus 3 minus or minus 1, or minus 1 minus or minus 3. This will be 2 volt, and resistance is 200 ohm. That means current will be 2 volt by 200 ohm. So, means 1 by 100 ampere. 1 10 ampere, milliampere. This is the diode current. In following figure, diode which is in forward bias. Have to check. Here N side is plus 5 volt, P side is plus 10 volt. It means it is forward bias. In case of B, the P side is minus 10 volt, N side 0. This is reverse bias because N side is smaller voltage, P side has smaller voltage than N side. The minus 10 is thus lower than 0. And for C, the N side is minus 12, P side is minus 5. That means it is forward bias. Okay, because P side is higher voltage, P side has higher voltage than N side. And D, here see P side is 0, N side is plus 5. This is reverse bias. That means A and C will be the answer. The last question is a Zener diode having breakdown voltage equal to 15 volt. Okay, 20 volt is applied here. 20 volt applied. Okay, and the resistance 250 ohm and 1 kilo ohm means 1000 ohm are connected. In so the circuit, the current through the Zener diode. We have to calculate current through the Zener diode. Okay, here Zener is in active condition. Suppose Zener may be inactive condition. If I choose this resistance very small, then the voltage across the resistance is less than 50, then Zener will be not activated. But here the current through the Zener, all the option is has some value. All the option have some value. Means Zener is inactivated. Suppose there will be a 0 option, then we have to check that current through Zener 0 or not. Here we don't need to check because all the options has value. So first I have to calculate current through 1 kilo ohm. Okay, because here the voltage through 1 kilo ohm is 15 volt because 15 volt Zener is used. So current through 1 ohm, 1 kilo ohm, I load. Suppose this is RL. Okay, IL will be 15 volt by 1000 ampere. Okay, and now I have to calculate current through 250 ohm. So suppose this is voltage 0 volt, this is 0 volt, this is 0 volt, this is 15 volt, and this point has voltage 15, and this point has voltage 20. Means the voltage difference of 250 ohm is 20 minus 15 voltage. Okay, and current through this IS, suppose this is series resistance RS, and IS will be 20 minus 15 by 250 ohm. Okay, 5 by 250 ampere. So here we can say 20 by 1000 ampere. I can write just multiplied by 4 denominator and upper point. So now IZ means the total current is IS. Okay, IS is divided into IL and IZ. So IZ will be IS minus IL. Okay. IS means 20 by 1000 minus IL means 15 by 1000 ampere, means 5 by 1000 ampere, means 5 milliampere. Okay, the answer will be 5 milliampere. That's all for today's class. Next class we will discuss about transistor, another device, transistor, and then after that we will go to the next chapter, digital electronics. Okay, thank you.